Okay, so I was asked to do vocab for chapter 9, so I'm going to do that right now. I'm not going to show my face, use the Android board. I'm actually going to do some things here, up here, and so you just listen to me talk. So parallel lines and symbols. Lines with the same slope that never intersect. Okay, their symbols are when you have little arrows like this on the line. That means those lines intersect. So those little arrows tell you that they intersect, that they're parallel, that they'll never intersect and have the same slope. Perpendicular lines. Perpendicular lines that intersect at 90 degrees. And if something's perpendicular, they'll put the 90-degree mark in there for you. So that little square means 90 degrees. Okay, that means those lines are perpendicular. Array, a part of the line that has an endpoint and extends infinitely. So our endpoint or the starting point is here, has a little dot. It extends indefinitely, means this arrow. So that is a ray. Vertex. Okay, the vertex, where two rays meet. So that point right there is the vertex. Transversal, a line that cuts through a pair of parallel lines. So as it says here, our two arrows show that this is parallel. So this line right here is the transversal. So the line that cuts through two parallel lines is called the transversal. Supplementary, angles that add up to 180 degrees. So we could have these two angles, here and here, add up to 180 because they make a straight line, or supplementary. You could have 1, 2, 3 angles that add up to 180. So supplementary means all of them add up to 180 degrees. You could put another angle in here. But all these angles combined add to 180 degrees. Okay, that's supplementary. Complementary. All the angles add up to 90 degrees. So 90 degrees. So you could put another angle in here. Those two angles add up to 90 degrees. You put a third angle in there. So these three angles add up to 90 degrees. Okay? So in this case, 1, 2, 3 angles here add to 90 degrees. Okay? Add to 90 degrees. Next, alternate interior angles. They are equal to each other. So interior means they're inside the parallel lines. Alternate means they're on the opposite side of the transversal. So angles 1 and 2 are alternate interior. Angles 3 and angle 4 are alternate interior. Corresponding. Okay? Corresponding means they're on the same side of the transversal and they skip, okay, down from one parallel to another. So angle 1 and angle 2 here. So angle 1 and angle 2 are corresponding. Angle 3 and angle 4 are corresponding, and they equal each other. Vertical angles, okay, means that they are across from each other and they equal each other. So in this case, 1 and 2, angles 1 and angle 2 are vertical. Angles 3 and 4 are vertical, so they equal each other. Same side interior angles. So that means they're on the same side of the transversal and they're inside the two parallel lines. So 1 and 2, and they add to 180. So angles 1 plus angle 2 equals 180 degrees, and those are same side interior. So angle 3 and angle 4 equal 180 degrees. They are same side interior. Adjacent angles. Angles that have a common vertex. So angle 1 and angle 2 are adjacent angles. Obviously you can have more than one angle there, but that's what that means. Exterior angle. On the side of the triangle when extending the sides. So the exterior angle is on the outside. So this is the exterior angle. Okay, on the outside. Okay. Remote interior angles. So we know this is our exterior angle. The two remote interior angles are the angles that are opposite the exterior and not touching the exterior. So angles 1 and angle 2 are the remote interior. Okay, are the remote interior. And one thing you need to know is the remote interior angles add together to get the exterior angle. So these two added together will equal the measure of the exterior angle. Angle similarity says if two angles of two triangles are the same measure, then the third angle will have to be the same. So it says if this angle and this angle are the same, and this angle and this angle are the same, that means that this angle and this angle have to be the same because both triangles have to add to 180 degrees. So that is angle similarity. So basically if you have two similar, if you want to see if two triangles are similar, if they have two angles of the same measure, they are, because that third angle has to be the same measure. Then we get into Pythagorean theorem. Okay, towards the end of the chapter that we're starting right now. So, Pythagorean theorem states the square of the small side plus square side plus medium side equals the square of the large side. So what Pythagorean theorem says? A plus B, A squared plus B squared equals C squared. Where C, the longest side of the triangle, is called the hypotenuse. The legs or the sides that make up the 90-degree angle are called legs. And the theorem is A squared plus B squared is equal to C squared. Where we always have to take the square root at the end, and we'll talk about that more and more as the chapter goes on. Now we're not always solving for C, so two other equations that I give you, okay, is A squared is equal to C squared minus B squared. B squared is equal to C squared minus A squared. Acute triangle. How can we tell if it's an acute? It says if the square of the small side plus the square of the medium side is greater than the square of the large side, it is acute. So this is A, B, C per se. if a squared plus b squared is greater than c squared, it is an acute triangle. Obtuse triangle. So again, we're going to go A, B, C. Just say. So it says if the square of the small side plus the square of the medium side is less than the square of the large side, it's obtuse. So a squared plus b squared is less than c squared, then it is obtuse. The last thing, no triangle. So one thing says if you have measurements, if these two sides don't add up to or greater than the longest side, they don't make a triangle. So 1 plus 4 is less than 10, no triangle. A counter example is if I have 7 meters, 8 meters, and 12 meters. 7 plus 8 is greater than or equal to 12. This makes a triangle. So hopefully this vocab will help you in the long run. Okay, we'll wait and see.